So what I'm going to show you here is how to do an experiment to work out what the balanced reaction is, or basically how to do any sort of stoichiometry experimentally. And so this is what we're trying to do. We're trying to work out what the balanced equation for this is. And the answer is 1 citric is to 3 sodium hydroxides. So what you sort of do is you just grab a whole different heap of combinations. So you grab 0.5 molar of these two things, so that's the same molarity, and you get like 9 mils to 1, 8 to 2, 7 to 3, 6 to 4, 5 to 5, and then you go down. And so you get all these different combinations of ratios, and then you plot them on a graph, and where the lines intersect is the correct ratio. And so the correct ratio for this, if you have a look, it's 3:1. And so if I'm using 10 mils, then the correct ratio would be 2.5 to 7.5. So if you have 2.5 of this, triple that over here is 7.5, and those two add up to 10. So they're the numbers we're looking for. Now the numbers we got when we drew the graph in there was 2.4 to 6.6. And so you divide both sides by the smallest number, and it's 1 to 2.75, and I was trying to get 1:3. So I had an 8% error there. Now, I wasn't actually sure if it was 2.5 or 3.5. I'd forgotten, and I was a bit worried. So this is another way you could do it. You can just make, when you get close to the correct answer, which is here, 3.2, which is the correct answer, you can then, well, I was doing repeats because I wasn't sure, and then I was getting 3.1. So it was clearly 2.5 to 7.5 was the best if I'm sort of cheating. And then I was trying to go each side. I went down to half a mil, and I guess I could go down to 0.1 mil if I used a micrometer pipette. So you could actually do it in that crude trial and error way and just use more and more accurate instrumentation and get it that way as well, but that's not how you're meant to do it. You theoretically can just do 2 experiments here, 2 experiments here, draw lines through, and where they intersect should be the answer. But as you can see, I got an 8% error, so it's not 100% perfect. If I knew it was to the nearest 0.5, which it is, then I could have just said it was this, because that consistently got the highest results. Okay, so that's how it's done. So graphing it, I'll show you the experiment soon, but graphing it, you just grab this, press the control button, and I split out the ones I wanted. I got rid of this crazy anomalous one and another one there, and then you just press insert scatter graph like that, and that's how you get it. Then you can plot 2 lines of best fit. So you have to split up this table here into 2 sections. And I got rid of the middle one. I could have put it in there. It works kind of the same, even with the anomalous results. So you can play around with the data. It sort of doesn't make any difference, to be honest. And so this is what it looks like. And so what I did here was I had a test tube. It was really difficult to get the 2 solutions to be the same temperature. I'm not quite sure. So this is me doing the 1 mil, and then I try and get the temperature to stabilize. Which never really happens. It sort of stabilizes for that, but I even put them in water bars and mixed them and weighed it. They wouldn't go the same temperature, so I sort of gave up in the end, and just, you'll see what I did here in the graphs. I just read the graphs up as best as I could. And so that's 1 mil of 0.5 sodium hydroxide, and then I add the large volume to the small volume because that will mix it for me. And so I'm about to add 9 mils of citric acid for my first reading. There we go, 9 mils of that. And you can see it drops down, and it's not meant to. It's meant to be the same temperature. So I start from there. That's what I did, 26.1, and it'll jump up to 26.5. So it's 0.4 temperature difference. So you can't do this without a data logger, right? You need the accurate instantaneous measurements, because I don't know. I made the citric acid up, and water doesn't gain or lose heat very easily, and I think that was causing issues, because when you add citric acid, it either cools down or heats up a little bit. This one here's at 5 mils, so 5 mils, dump in another 5 mils, and then it jumps up. So that's 26.2 to 28.7. Okay, so I just keep on doing that. That looks like a 4 to 6. And then I'll just go into the graphs, how I analyze them just a little bit more. So I thought the temperature stabilized, and then I add the other thing, and it was colder, and it made it drop. So I thought, okay, fine, I'll go here. I'll go to the nearest 0.1. So I probably went 26.1 or 26.0. And then I took that as the highest reading, and then it started to cool down, and then that's where I put the next thing in, and I'm thinking it's stabilized, and then I added the citric to the NaOH or vice versa, and it dropped, so that's where I start and that's where I finished. So that's where I start, that's where I finished. Okay, so you need a temperature data logger and you'll be fine. Okay, so that's how you experimentally determine what a balanced equation is. Okay.